What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 5, Section 4, Dividing Polynomials. Let's do it. If division of a polynomial by a binomial results in a remainder of 0, what can be concluded? So the thing is, it's just like regular division. Think about if you divide a number by another number and there's no remainder. You'd say then that number is therefore a factor of the number that was being divided, right? So it's the same idea. So if you divide a polynomial by a binomial, you have a remainder of 0. It is therefore a factor of that polynomial. That's the answer. Done. So for this one, we're going to use long division to divide. We're going to divide this by this. So we're going to set this up as follows. We're going to do that big polynomial. That's what's being divided. That goes on the inside, just like regular long division. And then the divisor goes on the outside here. And then as we do the division, we just look at these leading terms. That's what we care about. So right now we're saying how many times does x go into x squared? And the answer is it goes in x times, right? X times x gives me x squared. So I'm going to throw an x up here. Now, I am putting it above the x. I'm kind of keeping it lined up like that. This is not necessarily mandatory. You could put it up here, but this is how the book does it, and this is how a lot of teachers do it, so I'm going to do it the same way. So we throw that x up there, and then now, just like regular long division, it comes down and multiplies both components of the divisor, so that gives us x squared minus x, right? X times -1 is negative x. And then we're going to subtract. So what I like to do with this is instead of saying how I'm subtracting, I'm going to distribute a negative. So negate, negate, and then I'm just going to add. Same thing as subtracting. X squared and a negative x squared, that becomes 0. 5x plus x is 6x. Now we're going to bring down the -1 again, just like regular long division. And then looking at these leading terms, x goes into 6x 6 times. That's a positive 6. So 6 again now multiplies x and -1. 6 times x is 6x. 6 times -1 is -6. Again, we're going to negate, negate, add together, cancels out. And that's what we want, right? -1 plus 6 is 5. So here is my quotient, okay? And here is my remainder. And to write our final answer, once we complete the division, just like if you're writing out an answer for a long division problem of just numbers, it's that quotient x plus 6, and then we throw that remainder over the original divisor, x minus 1, whatever's on the outside. There's your answer. Boom, done. For this one, we're going to set it up in long division style with this on the inside and the divisor here on the outside. Again, we're going to just look at the leading terms here. So I'm going to see how many times does x go into 3x squared, meaning what do I multiply x to get 3x squared? That would just be 3x. So I'm going to place the x's like this on top of each other. That's kind of optional, but we'll do it this way. And then now we're going to multiply against both of these guys, just like standard long division. So 3x times x is 3x squared. Plus 21x, and then we're going to subtract, but I like to say negate, negate, right? Add a negative, and then we just add the two. So 3x squared plus negative 3x squared cancels out. 23 plus negative 21 is positive 2x, and bring down the 14. Then how many times does x go into 2x? Again, look at those leading terms. It goes in twice. 2 times x is 2x. 2 times 7 is 14, and look at that, it's perfect. So as we negate, negate, both of these are going to cancel out to get a remainder of 0 and a quotient of 3x plus 2. That's the quotient. And then if we write out our final answer, we say 3x plus 2, which is the quotient, plus the remainder over the divisor, but the remainder is 0, so there's our final answer. Done. For this one, let's go ahead and set it up in long division. So we got that first polynomial inside, the second binomial on the outside. And then again, we're looking at the leading terms. How many times does 6x go into 6x squared? Or what do I multiply by to get 6x squared? That would be just a single x. And then we multiply against both of these. X times 6x is 6x squared plus 5 times x, which is 5x. And then we subtract. Again, I like to say add a negative and then just add. So 6x squared plus negative 6x squared cancels out. Negative 25x plus negative 5x is negative 30x. Bring down that negative 25. Now, how many times does 6 go into negative 30x? Negative 5 times, right? Negative 5 times 6x gives us that negative 30x. And again, that's what we want. We want to match up this with that front term. And we did that. We got negative 30x, and then negative 5 times 5 is negative 25. Look at that. It matches up perfectly. So then we negate, right? Multiply by negative, and then we add. That cancels out, and that actually cancels out as well. So we get a remainder of 0, and we get a quotient of x minus 5, which means our final answer is x minus 5 plus the remainder over the, what's it called, the divisor, but there's no remainder, so this is the final answer. Boom, done. For this one, let's go ahead and set it up as follows. And looking at the leading term, what times x makes it 2x squared, or how many times does that go into 2x squared? Two ways to think about it. I'm going to multiply by 2x, and then we multiply and we get 2x squared. Again, that's the idea, matching up the leading terms. Don't worry about the second term. But then we also have to multiply against the 2, and then we get positive 4x. Then we're going to subtract the bottom part, or as I like to say, negate, distribute a negative, and then just add. Same thing. Those cancel out, and then negative 3x plus negative 4x is negative 7x, and then you bring down a 2. And then x plus 2, we say, how many times does that go into negative 7x plus 2? Just think about those leading terms. We multiply by negative 7. Negative 7 times x is negative 7x. It's matched up. That's what we want. Negative 7 times 2 is negative 14. And then we're going to subtract, aka negate. Those cancel out. 2 plus 14 is 16. So we have a remainder of 16 and a quotient of 2x minus 7. And we put it all together to get our final result. We get 2x minus 7. That's just the quotient. And then we take that remainder and we throw it on top of the divisor, which is that piece outside, over x plus 2 for the win. Boom, done. For this one, we're going to set it up in long division. And that first polynomial goes on the inside, the divisor goes on the outside. And then we're just looking at the leading terms at first, right? How many times does 3x go into 3x squared? It goes in x times, right? X times 3x is 3x squared. And then x times 1 is x, right? 1x. And then we're going to subtract, or as I like to do, negate, distribute a negative, and then add, same as subtracting. So these cancel out, and then negative 5x plus negative x is negative 6x, bring down the positive 4. And then we say, how many times does 3x go into negative 6x? It goes in 2 times, or negative 2 times. We're trying to match them up. And then we distribute to both of these. Negative 2 times 3x is negative 6x. Negative 2 times 1 is negative 2. And then last but not least, we subtract, aka negate, add these together, cancels out. 4 plus 2 is 6. So we have a remainder of 6 and a quotient of x minus 2. And we put it all together, we get the quotient x minus 2 plus that remainder over that divisor, which is 3x plus 1 for the win. Boom, done. For this one, we're going to set it up in long division. The first term goes inside. The second term is the divisor goes on the outside. And then we look at the leading terms. How many times does x go into 2x cubed? Meaning, what do I multiply this by to get that? It would be 2x squared. And again, I'm just lining these up. That's a little bit optional, but it does keep it nice and organized. So 2x squared times x, because now we got to multiply, and we got to multiply against both of these. That first gives us 2x cubed, which is what we want. 2x squared times 3 is 6x squared. And then we're going to subtract, or as I like to do it, say negate, distribute a negative, and then add together. These cancel out. 3x squared plus negative 6x squared is negative 3x squared. Bring down that negative 4x. And then again, how many times does that go into that? So I multiply by negative 3x, because when I do that, negative 3x times x gives us that exact match of negative 3x squared. Negative 3x times positive 3 is negative 9x. And then again, we subtract, aka negate. Those cancel out. Negative 4x plus 9x is 5x. And then we bring down that 15. Last but not least, how many times does x go into 5x? It goes in 5 times. 5 times both of these. 5 times x is 5x. 5 times 3 is 15. And then again, we subtract, aka negate. Look at that. It cancels. And we get a remainder of 0. And then we also get a quotient up here of 2x squared minus 3x plus 5. So then we give our final resultant polynomial. We get 2x squared minus 3x plus 5 plus the remainder, but the remainder is 0. So this is the answer. Done. Now we're going to divide the polynomial using something called synthetic division, which is pretty cool. So I'm going to show you how it works. What you do is, for the divisor, you take the opposite of this term, right? It's negative 4, so you put positive 4 in a little box like this. Another way to think about it is it's always x minus something, so whatever comes here, you're going to put in that box. If it was x plus 2, you'd actually put a negative 2, but we'll see an example like that in a later problem. So we put that there. Then what do we put over here? We put the coefficients of each of these terms in that order of degree, right? So x cubed, that 2 goes first, then that negative 6 goes second, negative 7 goes third, and then the constant at the end, 6. Okay, and now I'm going to show you how synthetic division works. First thing is we drop the 2 straight down, so it drops down. Then it multiplies that number up there. 2 times 4 is 8. Now we add negative 6 plus 8 is positive 2. Again, I repeat, I'm going to multiply times 4. Again, 2 times 4 is 8. We add negative 7 plus 8. That's positive 1. One last time, we multiply. 1 times 4 is 4. We place that here. 6 plus 4 is 10. And that's how we do it. It's pretty quick. And now we get our final polynomial. So the cool thing is, since this started as a cubic polynomial, this first number is actually going to be one level down, 1 degree down, meaning x squared. So our final answer is 2x squared. Then this corresponds with a single x. This corresponds with our constant. You see how it's kind of like a countdown, 2, 1, 0. And then we take that final remainder and we throw it over the divisor, which was that binomial x minus 4. That is how we get our final answer. Boom, done. So for this one, we're going to set it up in our typical synthetic division format, except there's a little issue here. The divisor, that coefficient of that first term is not 1. So we got to get that to 1 if we want to use synthetic division. So the first thing I'm going to do is I'm going to factor out a 2, and then it's 1x plus, and then if we're factoring out a 2, we're dividing by 2, so that 1 becomes a 1/2. So now we can divide. And so what we're going to do is we're going to look at this binomial, and we're going to take the opposite of that value. And then this 2 on the outside is a reminder that at the end, we need to divide everything in the quotient by 2. Okay, so we'll leave that alone. But for now, that means in the box, we can place a negative 1/2. And then up for the numbers for those coefficients of this polynomial, we place the 4 again in order of degree. So then second degree would be negative 12, then negative 5. Don't forget those, those negatives that stick to the numbers. And then for the last one, for the constant, it's negative 1. And then we do synthetic division as per usual. Drop the 4 times negative 1/2 is negative 2. Add these together. Negative 12 plus negative 2 is negative 14. Multiply by negative 1/2, that's 7, and that goes here. Add these together. Negative 5 plus 7 is 2. Take that again. See that pattern? It's always multiplying this value up here. 2 times negative 1/2 is negative 1. And we add together and we got negative 2. So here's the quotient. So I want to take that quotient, and then like I said, because of that 2 on the outside, we want to divide every value. So now it becomes 2. And then as we're writing out our final answer, this corresponds with not third degree, but 1 degree down when we do synthetic division. That first thing is going to be not x cubed in this case, but x squared. Negative 14 divided by 2 is negative 7, and that gets with an x, and then the last 2 is our constant. So we've halved everything. And now this value, you don't need to take half of. The remainder you can leave as is, as long as you place it over the original divisor, which is 2x plus 1. So that's the protocol. That's how you get the final answer. Boom, done. So here, because we have x plus 3, what goes in the box for synthetic division is the opposite of that, which is negative 3. And then over here, we have the coefficients in order of greatest degree to least degree. 3, negative 2, 1, right? 1x, and then negative 4. Now we're going to go through the process. First, we drop the 3, then we multiply it times what's in the box. 3 times negative 3 is negative 9. Negative 2 plus negative 9 is negative 11. Take that, multiply against negative 3. We get positive 33. Add these together, we get 34. Multiply 34 times negative 3. That's negative 102. Negative 102 plus negative 4 is negative 106. So now as we write our final answer, we get 3x squared. Why am I choosing x squared? Because the greatest degree here was x cubed, so we're dropping it down by 1, right? That makes sense because we're dividing by an x. So we have 3x squared minus 11x, right? And we drop it 1 degree from this, so x squared. Next term, next number goes with x. Then this one is our constant alone. And then last but not least, we have that remainder, negative 106, and we divide that by the original divisor, which is x plus 3. Boom, done. For this one, once again, we have a leading coefficient. So before we can begin with synthetic division, we've got to factor that out. And then we have x minus 3 divided by 2 is 3/2. Now we can set up synthetic division with the opposite of this value, which is positive 3/2. That goes in the box over here. And then we list our coefficients in order. We got 2, 7, negative 13. Don't forget the minus sticks to the number, and negative 3. Drop a line below and begin. So first we drop this 2, then we multiply against the box. 2 times 3/2 is 3. 7 plus 3 is 10. 10 times 3/2 is 15. We put that here. Add these together. Negative 13 plus 15 is 2. 2 times 3/2, that's a positive 3. And look at this. We get a nice remainder of 0. But don't forget, we factored out a 2, so we still have to divide everything in the quotient over here by 2. So that becomes 1. Now, 1 gets paired with the first variable, which is a drop down from x cubed, meaning x squared. So I don't even need to write a 1. I can just say x squared. That is 1x squared. Then the 10 gets paired. Oh, sorry, the 10 has to be divided by 2. Then that becomes a 5 that gets paired with the next degree down, which is x. And then 2 gets divided by 2 and becomes a single 1 as a constant. And since there is no remainder, this is the final polynomial answer. Done. For this one, once again, in the box, we're going to put the opposite of that 4 value, which is negative 4. But this is an interesting one because there's a missing x, right? Normally you have x cubed, x squared, x, and then the constant, but they're missing one. So we have to remember that for synthetic division. I'll show you how we account for that. So first we put the 4 for the x cubed, then negative 5. Now, since we could say it's like 0x, right? The x isn't there. We have to put a placeholder of a 0. Otherwise, it won't work. And then we got the constant at the end. Now let's begin. Drop the 4. 4 times negative 4 is negative 16. Negative 5 plus negative 16 is negative 21. Negative 21 times negative 4 is 84. 0 plus 84 is 84. Last but not least, 84 times negative 4. What is that? Negative 336. And now we add this to 13. We get negative 323. Okay, now we can write out our answer. So first we have 4. Since that was x cubed, we pair it with one level down, which is x squared. Then the negative 21 goes with an x. It's just sort of like a countdown by degree as we go from here. Then we got 84x. And then we got our remainder of negative 323. So that goes on top of the original divisor, x plus 4. And there's your answer. Boom, done. So for this one, we're going to set it up with the opposite of that, which is positive 7 in the box, and then we got the coefficients in order. So first, that's 1x cubed. That's negative 21x squared. That's positive 147x, and then negative 343. Now let's go through the process. So first, we drop that 1. Multiply 1 times 7 is 7. We add these together, we get negative 14. Negative 14 times 7 is negative 98. 147 plus negative 98 is actually 49. Then last but not least, 49 times 7 happens to be, I know this because it's 7 cubed, I got it memorized, it's 343. Then we add these together and that gives us a nice 0. So that's our remainder. And then the final answer is therefore going to be 1 times x squared, can just be x squared, minus 14x plus 49. See how I do that degree countdown, right? X squared, x, and then the constant. No remainder, so that's it. Boom, done. For this one, to begin with synthetic division, we got to factor out a 3 first, and that becomes x minus 1/3. Okay, now we can take the opposite of this value and place it up here in our box, which is positive 1/3. And then we're going to list out the coefficients in order. So first we got 9, but then there's no x squared. That means we have to put a 0 as a placeholder for that x squared. Then we got negative 1x, so that's a negative 1, and then we got a 2. Now let's do our thing. So first we're going to drop the 9. And the 9 multiplies the 1/3, and that's 3. 0 plus 3 is 3. 3 times 1/3 is actually 1. Negative 1 plus 1 is 0. And then last but not least, 1 times 1/3 is 0. 0 plus 2 is a remainder of 2. Now, before we write our final answer, we got to divide each of these values by 3. Not the remainder. Remainder's chilling, but we got to divide by that thing that we factored out up there. So 9 divided by 3 is 3, and then since we started with x cubed, we're going to go with x squared for this one. 3 divided by 3 is 1, so that's 1 times x. Notice how we decrease in degree by 1 as we go down. And then 0 is the constant, so we don't have to write that. But then there's our remainder, and that goes over the original divisor. That's why you don't have to do any additional division or anything like that. So 2 over 3x minus 1 for the win. Boom, done. For this one, we're going to put the opposite of this in our little box over here. We got -1, and then we've got the coefficients in order. So first we got 1x to the fourth, 1x cubed, -3x squared, -2, and +1. And let's go. Drop the 1. 1 times -1 is -1. Add these together. That's 0. 0 times -1 is 0. -3 plus 0 is -3, right? We're adding these. -3 again multiplies that top number. -1 becomes +3. 3 plus -2 is +1. 1 times -1 is -1, and that gives us a nice remainder of 0. Almost looks like a 6, but that's 0, sorry. And then now we got our final answer, 1x to the third, right? 1 less than the degree there. So x cubed plus 0x squared, don't need to write that because that zeroes out, minus 3, and that's going to be x, right? We skip the x squared, and then plus 1 is our constant, and since we have a remainder of 0, we don't have to write anything else, so there's your final answer, done. So for this one, we're going to put the opposite of this in our little box like so, -3, and then we place the coefficients in order. 1x to the fourth, 2x cubed, -3x squared, +2x, and 6, and then we drop a line here, and then we drop it. 1 comes straight down. 1 times -3 is -3. 2 plus -3 is -1. Take that, multiply against the number in the box. -1 times -3 is 3. Add these together, that's 0. 0 times -3 is 0. 2 plus 0 is 2. 2 times -3 is -6. 6 plus -6 is 0. So that's our remainder. So that's pretty cool. And now we list our final polynomial, starting with the third degree, right? That's 1 less than the beginning polynomial. So 1x cubed, or I can just write x cubed, minus 1x squared, or I can just write x squared, right? Plus 0x, don't have to write that. And then 2 is our constant, so we just put a 2 there. And since there's no remainder, this is the answer. Boom, done. For this one, let's start with that synthetic division by taking the opposite of this value, which is 2, throwing it in the box, and then the coefficients in descending order of degree. So we got 1, -8, 24, -32, and 16. So this is a long one. And let's go through synthetic division. First, drop the 1, then multiply against that box number, which is 1 times 2, which is 2. Add. -8 plus 2 is -6. Again, multiply against 2. -6 times 2 is -12. Add 24 plus -12, that's 12. Times again 2, which is 24. -32 plus 24 is -8. Again, times 2 is -16. And look at that, we get a remainder of 0, which means our resultant polynomial is, after the division, 1x to the third. I'm choosing x to the third because it's 1 degree less than what we started with in that first polynomial, minus 6, and then we do the stair step down, minus 6x squared, right? Cubed, squared. Next is going to be 12x. And last but not least is that -8 constant. Since we have no remainder, this is the final answer. Boom, done. We're going to start by setting this up for synthetic division with the opposite of -3, aka 3, up in the box. And then we have the coefficients. X to the fourth, that's coefficient of 1. Then we have -12. We have 54. We have -108. And that 81 at the end for the constant. All right, let's see what happens. Drop the 1, multiply against the box number, that's 3. -12 plus 3 is -9. Times 3 is -27. Plus 54 is +27. Times 3 is 108, right? Or sorry, no, that's not 108. What am I saying? It's 81, excuse me. 27 times 3 is 81. Plus -108, that's -27, right? And then -27 times 3 is -81. Plus 81 is 0. And so that's a remainder of 0, which is cool. And then we have the resulting polynomial, 1x to the third, because we start with 1 degree lower than what we started with for the first polynomial. Then we stair step down, minus 9x squared plus 27x to the first, minus 27. And since there's no remainder, this is the final polynomial. Boom, done. So for this one, as we begin with synthetic division, we first want to factor out that 2 in the divisor, and that gives us an x plus 1/2. And now we can begin by taking the opposite of this value into the box, which is -1/2. And then we're going to write out those coefficients in descending order. 4, 2, -4, 2, 2x, right? And then +2, the constant at the end. And then we just got to remember that everything that we get down here, we must divide it by 2 to get the final polynomial. So we're going to drop the 4. 4 times negative 1/2 is negative 2. Negative 2 plus 2 is 0. 0 times negative 1/2 is 0, plus negative 4 is negative 4. Negative 4 times negative 1/2 is positive 2, plus 2 is 4. 4 times negative 1/2 is negative 2, which means we have a remainder of 0, which is pretty nice. Because in our final answer, we get these as the coefficients. But before we do that, we must divide each and every one by 2. So we get 2, 0, of course, still, negative 2, and 2. Now we start with this coefficient. Since we started with x to the 4th, we drop it down to x to the 3rd by 1 degree, 0x squared minus 2x to the 1st plus 2 as the final constant. And there is your answer. Boom, done. For this question, we're using synthetic division to see if this binomial is indeed a factor of this polynomial. And the way we'll know that is if we get a remainder of 0. So let's check that out. So first, again, we put the opposite of that constant in the box, and then we put the coefficients in descending order, 3x to the 4th and negative 6x cubed. There is no x squared, so we need to put a placeholder of 0, because that's like 0x squared is another way of saying no x squared. Then negative 5 and positive 10. Now let's carry it out. We drop the 3. 3 times 2 is 6. 6 plus negative 6 is 0. 0 times 2 is 0. Add those together, that's 0. 0 times 2 is 0. Add to negative 5, we get negative 5. And negative 5 times 2 is negative 10. And that is a 0. And guess what? With the remainder of 0, yes, it is a factor. And then now we want to put it in factored form. So again, we factored out or divided by an x minus 2. And what do we have left inside? Well, here are the coefficients that 3 matches up as the first term with 1 less than x to the 4th, right? We're going 1 level down from that, so it's 3x cubed. Then I didn't leave much room here because we have a 0 and a 0, right? That would be 0x squared, 0x, so those we don't worry about. And then just the constant right here at the end, minus 5. So there's our factored form, boom, done. For this one, to see if this is indeed a factor of this, we're going to carry out synthetic division, looking for a remainder of 0. If it's a remainder of 0, yes, it is indeed a factor. So let's throw the opposite of this guy up here. And then we've got the coefficients in descending order. So 4x to the 4th, 0x cubed, notice there's no x cubed, negative 15x squared, 0x, and then negative 4. And these placeholders are very important because you won't get the right result if you don't put the placeholders. Now, let's carry it out. So we're going to drop the 4, and 4 times 2 is 8. 8 plus 0 is 8. 8 times 2 is 16. And then we add these. Negative 15 plus 16 is 1. Again, multiply. 1 times 2 is 2. 0 plus 2 is 2. 2 times 2 is 4. Negative 4 plus 4 is 0. So because we have that remainder, we know, yes, it is a factor. And then if we want to express this in factored form, I first put this guy, that factor or that divisor, if we think about this as carrying out synthetic division, times that resulting polynomial, which is 4. We're going to need more room here. 4x to the 3rd, right? Because we're starting with 1 degree less than what this started with, plus 8x squared plus 1x, and then last but not least, that constant. There's your final factored form. Boom, done. So for this one, what we're doing is we're placing the opposite of this again in the box, and we're carrying out synthetic division, and we'll know if this is a factor if, again, we get a remainder of 0. So let's place these constants as 3x to the 4th, 1x cubed, 0x squared, negative 3x, and then the constant at the end. So as we drop the 3, 3 times negative 1/3 is negative 1. Then we add these guys, and we get a 0. 0 times negative 1/3 is 0. Add 0 and 0, we get 0. 0 times negative 1/3 is 0, plus negative 3 is just negative 3. And then we have negative 3 times negative 1/3, which is positive 1, we get 2. This means that we do have a remainder. It's not a remainder of 0, which means this binomial here is not a factor of the big polynomial. So no, boom, done. Okay, so for this one, we know we've already got this polynomial piece here, and we're trying to figure out the other binomial that we can glean from the fact that we have an x-intercept right here at 1. So what we imagine is if we got an x-intercept at 1 in factored form, that means x minus 1 has to be one of the binomials, right? Because if we plug in 1, we'd zero out the entire polynomial. So that makes sense. And then we know we have another factor of x squared plus 2x plus 4, which means to get the final polynomial, we just string those together, right? We multiply them together, and we can leave it as this. We don't have to simplify in the back of the book. They just leave it as the product of these two. Boom, done. For this one, we know that we have a factor of x squared plus x plus 1, and then we also have a 0 here at 5, which means that in factored form, we'd have x minus 5 as a factored binomial, because plugging 5 in would zero this out, hence giving us that nice x-intercept. And then the other factor is x squared, as they're giving us, plus x plus 1. So to get the final polynomial, we multiply these two known factors, and that is your final answer. We're not going to FOIL it out because this is how they leave it in this format in the back of the book. So we're good. Boom, done. So for this one, we're meant to use synthetic division, and it might look a little funny, but remember, this fraction symbol is the same as a divide symbol. So it's this divided by this. So as we did in previous questions, we're going to take the opposite of the divisor, 2, right, or this part of the divisor I'm saying, that's -2, so it's 2, inside, and then up here, we're going to put the coefficients of the top part. That's what's being divided, that top polynomial. So the coefficients first of x cubed in descending order is 4. Then we have 0x squared, right? There's no x squared, 0x, no x. And then the -33 is the constant. So you got to remember these placeholders are very important. Now let's run it through. We drop the 4. 4 times 2 is 8. 0 plus 8 is 8. 8 times 2 is 16. 0 plus 16 is 16. And then again, 16 times 2 is 32. -33 plus 32 is -1. So here's my remainder, okay? And the quotient is therefore going to be this. 4, and then we got x squared, because we started with x cubed, so this is always going to be one level down. 4x squared plus 8x plus 16. That's the quotient. And so this is all this is asking for, the quotient and the remainder. There you have it. Boom, done. For this one, once again, we're dividing by this bottom binomial, and to use synthetic division, we take the opposite of this value, which is 1. We throw that in the box. And then we have the coefficients of the top part with the polynomial being divided, which is 3. And then there's a 0x squared, right? 3x cubed, 0x squared, a 2x, and then a -5, and let's run it through. So we drop the 3. 3 times 1 is 3. 0 plus 3 is 3. 3 times 1 again is 3. 3 plus 2 is 5. 5 times 1 is 5. 5 plus -5 is 0. So this last part is the remainder, which means we have a remainder of 0. And then the quotient is comprised of these pieces, which would be, and again, these are coefficients, so it's be 3. And then since we started with x cubed, this first one is going to be one level down, which is x squared. Then that one goes with one level down from that, which is x. And there's the constant 5. So this right here is the quotient. This is the remainder. Boom, done. So for this one, we're dividing by this binomial, and that's the polynomial that's being divided on top. So we start with synthetic division by taking the opposite of the second piece, which is -2. That goes in the box. And then we take the coefficients of the top polynomial that's being divided. So it's 1x to the 4th, 0x cubed, 0x squared, 0x, and -22, right? We have to add those 0 placeholders, otherwise this won't work. Now, let's do our synthetic division. We drop the 1. 1 times -2 is -2. Add these together, we get -2. Again, multiply times the box. -2 times -2 is 4. 0 plus 4 is 4. 4 times -2 is -8. 0 plus -8, -8. And then -8 times -2 is 16. -22 plus 16 is -6. So this is our remainder. And then to get the quotient, it's 1 times, one level down from x to the 4th, which is 1x cubed minus 2x squared plus 4x. See how the degree keeps dropping. Boom, boom, boom. And then that last -8 is the constant. So this is the quotient. And then we got a remainder of -6. Boom, done. So for this one, I know it's mentioning the use of technology, but we can actually just go ahead and plug in and do this by hand, which is what I'm going to show you. And there is a pattern here. Let's go ahead and do this. So it's really x to the 7th plus 1 divided by x plus 1. So we can carry the synthetic division out, right? We put in the opposite of 1 here, which is -1. And then we start with the coefficient. So it's 1x to the 7th, 0x to the 6th, x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st. Those are all zeros, and then a 1. So now if we carry this out, we can figure this out. So first we drop the 1 times -1 is -1. Boom, added together, we get -1 times -1 is 1. Added together, 1. 1 times -1 is -1. Added to 0, -1. You see this flip-flopping. So you can kind of see this pattern here. It's going to go back and forth, back, and then here it's kind of interesting, right? Let's fill all this in. So this would be 1, this would be -1, this would be 1, and then now we get -1 plus 1, which is, excuse me, a remainder of 0. So then now we can see that the result following this pattern is 1x to the 6th. We start one level below x to the 7th, minus x to the 5th, plus x to the 4th, right? That's this guy, minus x to the 3rd, plus x squared, minus x plus 1, and there's no remainder. So this is the result. Whoops, boom, done. So for this one, once again, I'm going to do this actually by hand. I'm not going to use technology. I'm going to plug in 4 for k. So we have x to the 4th over x plus 1. So using our synthetic division, we plug in the opposite of this, -1, into the box, and then the coefficients of that top polynomial, which is 1x to the 4th, 0x cubed, 0x squared, 0x, and then a constant of 0. So let's go ahead and carry this out. We drop the 1. 1 times -1 is -1, plus 0 is -1. Times -1 is 1. Again, it's doing that flip-flopping. 0 plus 1 is 1. Times -1 is -1. 0 plus -1 is -1. Times -1 again is 1. 0 plus 1 is 1. So we have a remainder of 1. So if we were to write this out, we have 1x to the 3rd. Why am I starting here? I'm starting 1 below x to the 4th. Then it's minus 1x squared plus 1x minus 1, and then that remainder of 1 over the original divisor, which was x plus 1. And there's your final answer. Boom, done. For this one, we got some imaginary numbers in the mix, so we're going to still use synthetic division the same way we have before, which is the opposite of the divisor constant, right? X minus something. That's going to go in our little box, and then we got the coefficients of 1x and 1. So let's carry it out. First, we drop the 1, multiply by I, and then we have 1 plus I over here for our remainder, which means then we have 1, which is 1 level down from x to the 1st power. That's x to the 0th power. That's just 1. So it's 1 plus I over that original divisor of x minus I. So there's our final answer. Boom, done. For this one, we're going to take the opposite of the denominator, that value, this I in this case, that's being added to x. So the opposite of I is -I, and then the coefficients of x and 1 up top. So that's 1x and 1, and then we carry out our typical synthetic division. Drop the 1. 1 times -I is -I. 1 plus -I is just 1 minus I. And then we convert it. So again, since this is x on the top polynomial, this is going to be 1 times x to the 0th power. This is x to the 1 power. So that's just 1, and then plus our remainder here of 1 minus I. And we always store our remainder in our final answer over the original divisor. That's the number on the bottom here, which is x plus I. There's your answer. Boom, done. Once again, we're dividing by x minus I. So for synthetic division, we take the opposite of that -I, which is positive I, and then we list out the coefficients. X cubed, that's 1. 0x squared, 0x, and then 1. And then let's go. Drop the 1. 1 times I is I. 0 plus I is I. I times I is I squared, which is -1. 0 plus -1 is -1. Then -1 times I is -I. 1 plus -I is 1 minus I. So this is the remainder. So now we can write this out. So we have 1x squared, right? We're starting 1 degree less than the original numerator of that, polynomial, and then plus I times x, right? This is going to be 1 degree down from the first, and then minus 1, that's our constant, and then plus that remainder of 1 minus I over the original divisor, which is x minus 1, or sorry, not 1, x minus I. So there is your final answer. Boom, done. So for this one, it's saying that we have a rectangle, and we know that the length is 2x plus 5. And we know the area is this. Well, here's the thing. How do we get area? We do length times width. And so that's what we're trying to find. We're trying to find what times 2x plus 5 is going to give us this. Well, the great answer to that is we do multiplication in reverse, aka division. So we're going to divide this area by the length to get the width, just like if we had numbers. So with this leading coefficient, it makes it a little trickier with this synthetic division. If that's what we choose to use, right? We're going to have to factor the 2 out and do a whole thing. Or we could do long division. So how about this? I'm going to show you. Let's go with long division just for the heck of it. So we got 4x cubed, and this is always a safe bet if you do have a leading coefficient. You can do synthetic again. Like I said in previous examples, you can see where I factor out the 2 and then do our thing, and then we just remember to divide the end result by 2 at the end. Let's go with long division because this is nice and safe. So we're only worried about the leading terms when we do long division. So first 2x goes into 4x cubed, 2 times 2 is 4, and then x squared, right? 2x squared times 2x gives us that perfect 4x cubed, and then 2x squared times 5 is 10x squared. Look at that. It matches up perfectly. Now I say negate, add these together, cancel, add that together, cancel. So that's nothing. And then we're going to bring down the next thing, which is 6x, okay? And then 2x goes into 6x. How many times? It goes in 3 times. 3 times 2x plus 5 is actually 6x plus 15. And this is kind of interesting because, you know, we haven't brought this 15 down yet, but we may as well because we have a binomial here, and we may as well have that constant. You could bring it down later, it won't make a difference, right? So we may as well drop it here since we have a binomial here, and then now we negate, aka subtract. We add these together. Look at that, zeros out, zeros out. There's our nice remainder of 0, which means when we divide by this polynomial, we get a perfect quotient of 2x squared plus 3. And that is our width, 2x squared plus 3. And just for fun, if you want to multiply this times this, you would see that you would end up with this nice polynomial. So 2x squared plus 3 is the width. Boom, done. For this one, we're given a box here, and we're given 2 of the 3 dimensions, okay? So we got a volume, and we have length, and we have width. And we're trying to find the height. Well, length times width times height gives us volume. So what does that mean? It means that if we take this starting polynomial, we first divide by 2x plus 3, and then divide that resulting polynomial by 3x minus 4, we're going to be left with the height. Now, long division would be nice since we have these leading coefficients, but I'm going to mix it up, and I'm going to show you how to do it as I have in previous examples, how to do this with synthetic division. It's just a little added step, and I think it'll be better because we have so much work to do on this one. So here first, I'm going to factor out the 2, and I've got x plus 3 halves. And then here, I'm going to factor out the 3, and then I've got x minus 4 thirds. So as we start, I'm going to divide by the opposite of this, which is negative 3 over 2. That goes in the box, and then we're going to place those coefficients, 12 x cubed, 20x squared, negative 21x, and then negative 36. And as we carry it out, we drop the 12. 12 times negative 3 halves, that's 4, what is that, negative 18, right? Yes, negative 18. 20 plus negative 18 is 2. 2 times negative 3 halves is negative 3. Negative 21 plus negative 3 is negative 24. Negative 24 times negative 3 halves is positive 36, and that's beautiful. We get a nice remainder of 0. And then I'm going to, oh, by the way, since we factored out a 2, we have to remember that we actually have to half this, okay? So we now have to divide each of these individual ones by 2, which really means we have 6, 1, and negative 12. Now I'm going to take this resulting polynomial, and I'm going to run it through division with the opposite of this, which is positive 4 thirds, okay? So we got 4 thirds. Let's set it up. We drop the 6. 6 times 4 thirds. I say 6 divided by 3 is 2 times 4 is 8. 8 plus 1 is 9. 9 times 4 thirds. I divide 9 by 3, which is 3 times 4 is 12. That's beautiful, and it zeroes out, which is what we want. We want no remainder. And then, again, since we factored out a 3, we have to divide each of these by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. And now, since we've done 2 divisions, okay, normally I'd be like, hey, this is going to start with x squared since we started with x cubed. But since we've run through 2 divisions by x, x cubed goes to x squared, goes to x. So the first constant coefficient 2, that just goes with the singular x, and then the 3 is our constant. So here is the polynomial that represents our nice height, 2x plus 3, boom, done. Once again, we got an expression for volume, and then we got the length and the width, and we must find the height. So you'll remember volume is length times width times height. So to get the height, we have to divide the volume by the length and the width. And we can do this one at a time. So let's go ahead and do that. Now I'm going to choose synthetic division because I think it's going to be a little bit more efficient given that we've got to do it twice. Just remember, with these coefficients in front of the x, I have to factor that out. So that becomes x minus 4/5. And here I have to factor out the 2. And that becomes x plus 3/2. So now as we carry out the division, first I'm going to take the opposite of this, which is 4/5. And that goes in the box. And then we're going to write out these coefficients in descending order of degree: 10, 27, 2, negative 24. So let's begin with that. So we drop the 10 times 4/5 is 8. 8 plus 27 gives me, what is that, 35. 35 times 4/5, excuse me, is 28. 28 plus 2 is 30. 30 times 4/5, 30 divided by 5 is 6 times 4 is 24. And that's what we want. It should go in evenly. There should be no remainder. Now, because we had factored out a 5 to get the final correct coefficients, we still have to divide every one of these by 5. So 10 divided by 5 is 2. 35 divided by 5 is 7. 30 divided by 5 is 6. Okay, now this is the new polynomial after dividing by this. So then we still have to divide by this guy. And via synthetic division, we take the opposite of this, which is negative 3/2, and let's run it. So drop the 2. 2 times negative 3/2 is negative 3. 7 plus negative 3 is 4. 4 times negative 3/2 is negative 6, and that's what we want, a remainder of 0. And again, we have to divide by 2 because we factored that out. So 2 divided by 2 is 1. 4 divided by 2 is 2. So since we started with x cubed, but now we divided by x, in x values twice, right? So we're dropping the degree not once but twice. So now that means our final answer is 1x plus the constant of 2, meaning x plus 2 is the representation of height. Boom, done. So here we have the volume of a cylinder, and it's good to remember that volume of a cylinder is pi times radius squared times height. So we know that this is the radius and we're trying to get the height. So what are we really doing? We're dividing by pi and we're dividing by radius squared, right? If I do that, boom, that cancels out. Boom, that cancels out. We're left with height. So let's take this. First we divide by pi. Well, that's nice and simple. That pi's just cancel out. Then we have to divide by the radius squared, meaning we're going to divide by this radius twice, really, if you think about it, right? 5x plus 1 and 5x plus 1. So we can do that in 2 different steps. So if I'm dividing by 5x plus 1 via synthetic division, I must first factor out the 5, and I'm left with x plus 1/5. So then we divide by the opposite of that 1/5, which is negative 1/5. Now let's write out those coefficients. We got 25, negative 65, negative 29, and negative 3, and let's go. So we drop the 25 times negative 1/5 is negative 5, plus negative 65 is negative 70. Negative 70 times negative 1/5 is positive 14, plus negative 29 is negative 15, times negative 1/5 is positive 3, and that gives us that nice remainder of 0, which we should have been expecting because this should go in exactly. And then don't forget, we have to divide all of these by what we factored out, which is 5. So really we have 5, negative 14, negative 15 divided by 5 is negative 3. Now we're going to run it again because we're dividing by this thing one more time. So again, I'm dividing by negative 1/5. Let's go. And then we got drop the 5. 5 times negative 1/5 is negative 1. Negative 1 plus negative 14 is negative 15. Negative 15 times negative 1/5 is positive 3. Plus negative 3 is 0. And since, again, we've factored out the 5, we have to divide this and this by 5. So we get 1 and negative 3. And since we've taken x cubed and we've divided twice, right? We're not dropping to x squared, we're dropping to x. So the 1 lines up with x. That negative 3 is the constant. So that means that our height for the cylinder is x minus 3. Boom, done. For this one, we've got the volume of a cylinder as this expression, and we know that the radius is x plus 4. So what is volume of a cylinder? It's equal to pi r squared times h. So if we're trying to solve for height, we need to divide both sides by pi r squared. Pi r squared, okay, cancels it out. So what does that mean? I'm dividing this volume by pi, which first I would just get rid of the pi, and then I'm dividing it by the radius squared, meaning I'm dividing it by the radius and then the radius again, okay? So we can set that up, and this is our nice radius here, which is perfect for synthetic division because there's no coefficient here. We don't have to factor. So we divide by the opposite of this value, and we're going to do it twice. So let's set it up. Opposite of 4 is negative 4, and then we got the coefficients of 3x to the 4th, 24x cubed, 46, negative 16, and negative 32. So let's do the first round. Drop 3. 3 times negative 4 is negative 12. Negative 12 plus 24 is 12. Times negative 4 is negative 48. Negative 48 plus 46 is negative 2. Times negative 4 is 8. 8 plus negative 16 is negative 8. Negative 8 times negative 4 is 32. 0 is the remainder, which is what we want. And then we run this through one more time, again with negative 4, because we're dividing by that polynomial twice, right? Or that binomial, I should say. It is a polynomial as well. But we drop the 3. 3 times negative 4 is negative 12. These two add together, we get 0. 0 times negative 4 is 0, plus negative 2 is negative 2. Negative 2 times negative 4 is positive 8. Those two add together, and again, a nice remainder of 0. So what does that 3 match up with? Well, again, we started as x to the 4th. We divided twice, so it drops 2 degrees. So that's 3x to the 2nd, right? 4th, and it goes 3, 2. And then 0x, and then negative 2 as the constant. So here we go. This is the value, the expression that represents height. Boom, done. I hope you guys enjoyed this video, and if you did, please click that like button. And if you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.